Hello guys, welcome back to my channel Algorithm Mind. My name is Hasan Khurram, and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach theoretical concepts as well as practical programming skills in topics such as data analysis, statistical analysis, machine learning and data science. So if you are a person who wants to learn Python from beginning, or you are a person who wants to excel his career in data science, I suggest you to subscribe to my channel and hit the notification bell icon button, because soon I will be posting videos related to statistical analysis in Python, which is again one of the core aspects for any data science professional. So in today's lecture, we are going to discuss about Pandas library in Python. Basically, it will be an introductory lecture on Pandas library in Python. So Pandas is a powerful Python library used for data manipulation and analysis. It provides convenient tools for exploring, cleaning, transforming, visualizing, and learning from data. So what are the data structures in Pandas? We have first a series, which is a one-dimensional array, or one-dimensional labeled array capable holding any type of data. Then we have a data frame. A data frame is a two-dimensional labeled data structure with columns of potentially different data types. Think of it as a tabular type of data where we have like column, and each column could contain a diverse each column has a different type of can hold a different type of data, but within that column the data must be of the similar value. Okay, so I mean, if the one column is actually a string type data, it has to be a string type data. One column is integer type data, it has to be integer type data. So that's the power for Pandas library, that it allows us to handle and manipulate data by dealing with series and data frame. So that was a little and brief introduction to Pandas library. Let's move on to actually the practical programming class. So where I will actually teach you how you can actually create your own data frame and manipulate that data frame or read values from that data frame. So in order to do that, the first thing we are going to do, we are going to import our libraries. We are going to import Pandas library, and we are going to import Matplotlib library and its module pyplot. Although we don't need right now this pyplot, so we can just skip it. So we are only dealing with Pandas libraries here. So we are going to import Pandas library by using this Python statement, import pandas as pd, and as pd here is alias. So that means that whenever we want to actually use this Pandas library, we will use pd instead of writing the whole pandas word. So once we have imported our library, let's move on actually creating data that we can actually convert into a data frame. So there are two ways we can actually do that. The first way is actually through creating a dictionary. The second way is actually creating a list of columns and their respective names. So let's first discuss how we can actually create a data frame from a dictionary. In order to create a data frame from dictionary, we first have to define the data in the format of dictionary. So this is the generic notation of dictionary. For those of you who don't know, who do not have an idea how to actually create a dictionary, I have a detailed tutorial video on dictionaries. You can check that video. I will put the link in my video description, so you can go and check that video. It's a highly resourceful video, so I suggest you to watch it if you don't have any idea of how to create dictionaries. So dictionaries are created by curly braces, and within the curly braces we will have key value pairs. So in this dictionary we have three keys: name, age and city, and then we have their associated values which are in the form of a list. The first one is actually a list of string. We have their names: John, Anna, Peter and Linda. Then the second list is actually a numeric list. We have the ages, and then the last one is actually again a string list. So this is how we actually created our dictionary. Now in order to convert that dictionary into a Pandas data frame, what we can actually do, we will use this method here, pd.dataframe data. That is, we will call our Pandas library as pd. So we are calling a Pandas library, then we are using its method data frame, and we are passing input argument our created dictionary. That will convert that dictionary into a data frame. So let me just run this code for you. So now you can see, and let me visualize this. So now you see that instead of like having let me also do something here. So let me also show you data. So you see that this was the data was actually the dictionary we have created, and by using this Python statement PD and method data frame, we were able to convert that dictionary into a data frame where we have column name, age, and city. So that's how you can actually create a data frame through a dictionary. Let's move on and discuss about how you can actually create dictionary from a set of lists. Okay, so if you recall that earlier, once we have where we are actually creating data from a dictionary, we actually are using list for the values that were associated with keys, name, age, and city. In the same way, we will initialize a variable names like names, ages, and cities, and we will assign values, string of list of string, a list of the numeric values, integer values, and a list of again for cities we will again have a list of string. So we have here we have declared three variables: names, ages, and cities. And how we can actually now create Panda data frame from these lists? So we are going to use this Python statement here. We will initialize a variable name df from list is equal to, then we call the Panda library, and after that we are going to use this method data frame, and within that method we are going to pass this input argument in the form of dictionary. So this by nature is again the same thing. Again it is being passed as a dictionary. So whatever we have written here, we are first converting that into a dictionary, then we are passing it as an input argument to this method. So again, although it might look different that we have created a list, then we have pass it as an input argument, but here it is a two-stage process. When we take the list, we convert those lists into a dictionary, then we put those dictionary as an input argument to this method data frame. So by using this method, we are also able to create data frame, because this thing here is also a dictionary. If you take this and write it down as temp is equal to this, and then I'm going to write print, and then within I'm going to write type in order to check its class, and within that class I'm going to pass this temporary variable which I created just to check its class. So you see that is actually a dictionary. So we have created the list, then take those lists to create a dictionary, then pass that dictionary to this method data frame. So you get the idea. Now let's move on to actually discussing about basic data manipulation in Panda data frame. Before we can actually discuss about data manipulation, let's briefly talk about this attribute. We have a number of attributes that we can actually use with Panda library. The first one is actually df.shape. df.shape is actually an attribute of the Panda frame, actually an attribute of the Panda library, and when we use df.shape, it is actually an attribute which returns the dimension of the data frame. The dimension which means that what are the number of rows and number of columns that are present in our data frame. df.shape actually returns a tuple where the first element of the tuple represents the number of rows and the second element of tuple represents the number of columns. So when I run it, you see that I have how many rows? I have 4 rows and 3 columns, which you can also verify through this output here. You have 4 rows and 3 columns. Now after that, there is another attribute of the Panda library that is called column. So df.column is an attribute that returns the label of columns. So basically it will give you the column names or the column labels of that specific data frame, and it returns an index object. So now you see that it returns an index object where we have name, age, city as the name of the column or the label of the data frame df. You can also verify that we have 3 column names or labels: name, age, and city. Now, let's discuss about df.describe method. This is a method in Panda library that actually help us to calculate the statics of the numeric columns in our data frame. So whatever the columns that are present in our data frame which has a numeric value, integer or float value, it will calculate its statics, and within the statics it will calculate the total count of that column, like how many null values are present in that column, and also like what is the mean of that column, what is the standard deviation of that column, what is the minimum value of that column, what is the maximum value of column, and it also give you the percentile. Like if you don't have an idea about percentile is such that if we have, for example, let's say we have like a value for 50 percentile is 31.5, so it means that 50% of the values in our data frame lie below 31.5 value. So this stands or give you some statics or give you a descriptive statics about your data frame or the column, specific column. So again, df.describe will give you the summary statics or statics of all numeric columns that are present within your data frame. Then we have another method which is called head. It is simply just displays the first few rows or first 5 rows of your column. This is actually quite helpful when your data frame is quite large and then the number of rows in your data frame exists like 1,000, even 10,000 values. So in that case, you can actually use this method df.head to actually visualize the first 5 rows of the data frame, and it gives you a brief introduction. It helps data analysts or data scientists to get a brief introduction to the data, like what is in the data, what kind of data columns are present in the data, what is the nature, object or data type. Okay, so that's what it means. Then now let's move on to actually discussing about the data manipulation part, where we actually learn how to actually can read specific values of specific column or specific element within a column. So that's what we are going to do right now. Right now we are more or less focused on how we can actually access a specific column from our data frame. If you go back and recall our column, our data frame, this is our data frame which has column name, age and city, and it has 4 rows, and the index of rows start from 0, 1, 2, 3. So in order to access a column of the data frame, we are going to use square brackets, and within those square brackets we are going to pass the column label in quotation marks. So for example, we have passed the column label name in quotation marks. So when we run it, we are able to get only the specific values of that specific column. If I change it to age, now you see I'm only able to get a series of one dimension array, and I'm able to only get the column that of age from the data frame. So that's how you can actually access a specific column in a data frame by using simple square brackets, and within those square brackets you will pass the label of that specific column. Now you learn how to actually access a specific column. You might be interested in assessing a specific row values. So how we can actually do that? We can do that by using this method log square bracket and then pass the index of the row or column. Okay, so in our case we have passed the index 0. In Python, index generally starts from 0. So for 0 it means we are accessing the values of the first row. So that's how you can actually access the elements of a specific row in Panda data frame by using this method log df, which is our data frame, and then we are applying the method log, and then within the square bracket I'm also giving the index here 0. But if I change the index to, let's say, 1, so it will give me the row value of the second row. Now the values has been changed because right now we are assessing the values of second row by putting in the index is equal to 1. So let me just also give you df, so you can then you have a better understanding what do we mean by that. So if you could go and look at the index one is actually at second row. So df.log method actually helps you to assess a specific element or a specific row in your data frame. Okay, so if I change it back to 0, you will see now I'm getting the values for the first row, John, 28 and New York. So that's df.log method actually help us to extract specific row elements. Okay, and we can also further narrow it down to a specific element too by specifying also the column. Let me show you what do I mean by that. So just like a basic notation, we have rows and column. For rows I have defined index to be 0. For column I will define index to be, let's say, name. So in this case we are actually assessing the data frame by their index label, not by the specific numbers. We are assessing it by their respective labels. Okay, so 0 is a label, not an index, and name is a label, index, but not an index in the form of 1, 2, 3. So let me show you right now. So right now you see that we have access only the John because we limited to the column name here. So that's how you can actually access specific element or a specific row of our data frame. Now you know how to actually access values out of our data frame. Let's move on and actually create a new column in our data frame, and that is quite easy to do. We simply just have to write our data frame df, then we will use the square brackets, then we will write the name of the new column that we want to introduce. So in our case we want to introduce the gender, so we will write gender in quotation mark, then we write is equal to, then we give it a list of values that we actually want to assign it. So we have given a list. It's exactly the same context as we have done earlier when we declare our data frame by the use of list here. So in the same way, we have declared a new column gender and we are assigning it to a list of string. And when I run it, you see that we have now indeed created a new column gender that has the values male, female based on the data we have put. Okay, so based on the gender, and if you see that indeed we do indeed in the okay. Now when you look at the data frame, we do indeed added a new column gender which has entities male, female. So that's how you can actually add a new column to your existing data frame. But what if you actually want to change or update the existing value of data frame? Like for example, you have this data frame, and for Anna, or let's say for John, you want to change it there to 32 or 33 instead of like 30. So how you can actually do that? So it's quite simple. We will use the same notation as we used earlier by using the .log method. Then we pass df.log, then we give the label of the index we want to reach. In our case, we want to reach the index 0, and also want to give the label of the column. In our case, we want to change the age, so we will give age. Now we have described our row and we have described our column. And then if you want to update the new value, we'll just simply put equal to sign and write the new value you want to actually update it. So I'm changing its value from 28 to 33. So now you see the new values have been updated. So that's how you can actually update the new value or update the new value by using ilog method. Now let's move on and discuss about how we can actually drop a column in our data frame. For example, you have imported an Excel data from an Excel file, and that contains multiple columns, and these columns are not of your interest and they are just unnecessary columns that you need to drop. So how you can actually drop that? Well, it's quite easy to do. We will use the function method called drop of Panda library. Okay, and we are going to pass 3 input arguments. The first input argument will be actually, we are going to use this Python statement here. First we will write data frame name df, then we are going to use a method which is drop, and within that method we are passing 3 input argument. The first input argument is actually the column name we actually want to drop. In our case, we want to drop the column city, which is not of our interest. Okay, for example, let's say the city is of not our interest. And then in the second argument, we are defining x is equal to 1. So what do we mean by x is equal to 1? So x is equal to 1, that means that we want to drop column. If x is equal to was 0, it means that we want to drop it by row. So there are two options for it, 0 and 1. 1 is defined for column wise and 0 is defined for row wise. So by drop method you can actually drop by rows or by column, but right now we are more focused on dropping it by column. So we have defined x is equal to 1. Then we have in place is equal to true. It means that when it sets to true, it means that it will modify the existing data frame we are using, which is df, and will drop the value. It will drop the column, and then it will return or update it to and return it. If it's false, then it will create a new data frame instead of actually manipulating or doing the updation on the existing one. So now, so if after writing this code, you will see that our city column is actually been dropped, and we are only left with name, age, and gender. So that's how you can actually use drop method in Panda data frame. Now let's go on and discuss about filtering in Pandas library, and it is a little bit complex concept here, but I will try to drill down into simpler steps so you can understand and comprehend it. So within the sprint function, I am using this line of statement. If you for a brief moment just also neglect that and focus on just this quantity here, df square bracket age greater than 25. If you recall our previous lecture, we say that in order to access a specific column, we are going to use this notation df then square bracket, then we pass the column label. In our case it is age. So by this doing so, we are able to access the values of the specific column, which in our case is actually age. Then we are using a conditional statement here, that we are checking whether those elements that are present in column age are greater than 25 or not. If those elements that are greater than 25, we will have a true statement, and if they are less than 25, then we have a false statement. So this whole line Python statement here, df under square bracket age is greater than 25, will give us a Boolean series of true and false. Okay, when we are using that Boolean series of true and false, we will actually create a mask. Okay, the mask is just like, okay, which help us identify whether those values, whether these values are greater than 25 or whether they are less than 25. So basically it's a mean of creating an index here. Okay, so where you know that only these specific indexes where value is greater than 25, and on some indexes the value is less than 25, and these indexes are created by a Boolean series of true and false. Once you have this Boolean series or indexes, now you can use that indexes to actually extract only those value where we have Boolean value equal to true. So where we have Boolean value to false will be dropped, and only true values will be adopted, and therefore we will have a reduced set of rows as compared to the original data frame, because we have filtered those values that are not greater than 25. So that's the idea behind filtering, and that's how you can actually create a filter mask here, by first creating a Boolean series, then using that Boolean series to filter out values, and you have a reduced filtered set of data frame. So now you can see that only those values, only those rows that have age greater than 25 are shown in the data frame, and those, for example, Peter age was actually less than 25 and it has been dropped in our case. Lastly, let's discuss about sort values. Just like we have implemented this method of filtering, in the same way we can actually rearrange the rows by a specific by using this method sort values. So how we can actually do that is quite simple. We will write our data frame name df, then we use those sort values method, and then we will define how we actually want to sort values by, or by which specific column we want to sort values by. So in our case, we want to sort values by age, so we'll use by is equal to age. So once we done that, now you can see that the values have been sorted by age, where the lowest one is starts at the beginning, and then the higher one start proceeding towards till the end. So that's how you can actually use sort values function. That's it for right now. I believe this was a quite comprehensive and introducing tutorial on Pandas library. I hope you understand the concept. If you have any question regarding this tutorial, or have any problems while writing your own code in Pandas library, feel free to write your questions or queries in the comment section below. I will be happy to help you out. As a reminder, I request you to subscribe to my channel and hit the notification bell icon button, because soon I will be posting videos related to statistical analysis in Python, which is again one of the fundamental or core aspect for any data science professional. So you have currently you have gained skills in Python basics, and you are right now trained to take the classes of statistical analysis, if you have taken all the classes of my tutorials related to Python programming right now. So thank you for joining me. I will soon catch you in the next video.